Practice for section 6.4. We're going to do a few problems together. In number 3, this triangle is isosceles, so is this one. Another thing you need to remember is these vertex angles are actually vertical angles. So if this one's 54 degrees, so is this one. If you know a vertex angle for an isosceles triangle, you can definitely find the base angles because the base angles are congruent, remember. So if you take 54 degrees away from 180, that's going to give you 126. Divide that by 2. That's going to give you 63 for both. We're dividing by 2 because they're both the same. We're going to skip down to number 8. Again, there's 2 isosceles triangles. This one has a vertex angle of 60. So the 2 base angles, they need to be congruent. You already used 60 degrees, so you have 120 left. 120 divided by 2 gives you 60 as well. So this triangle is isosceles. But furthermore, it's equilateral. All of the angles are the same, and all the sides are the same length. This one down here, this angle is 45. That's one of the base angles. So the other base angle is also 45. So remember, we talked about equilateral triangles, how all of the angles are 60. We've also talked about isosceles triangles where the acute angles are 45. That means the vertex angle is 90. That's a 45, 45, 90. That's a 60, 60, 60. Skip over to number 12. Here's an isosceles triangle. That's a base angle of 42 degrees. That means this angle over here is 42 degrees. Total, that's 84 degrees. That leaves you with 96 degrees for this angle. Now, there's nothing you can take from this triangle over to this triangle. There's no linear pair. There's no vertical angles. There's no right angles. They tell you the vertex angle here is 88. That means these 2 angles add together to give you 92 because those are the base angles. So 92 divided by 2 gives you 46. I know that's a little tough to see there. Here's a diagram here. It's triangle ADF. They're telling you the distance from A to D is x plus 6, and the distance from D to F is 3x minus 10. Well, those are your legs. The legs are the same length. So set them equal. We're going to subtract x from both sides. We're going to add 10 to both sides. So x is 8. That's not what they ask you to find. They ask you to find distance from A to D. Well, distance from A to D is 8 plus 6. 8 plus 6 is 14. You can check your work here as well. 3 times 8 is 24. 24 minus 10 is the same 14. In number 14, triangle ADH, that's this little guy over here now. The measure of angle ADH, that's this guy, is 2x minus 4. Find the value of x. Well, they don't give you anything else, but you know this angle here is 46 degrees. This triangle is congruent to this triangle. We have 2 of the 3 angles in this triangle. If that's 46 and that's 90, this one must be 44 degrees. There's nothing else that it could be. So that angle, I'm kind of out of room, I'll just go down here, that's 2x minus 4, that is the 44 degree angle. So set up an equation so you can figure out what x is by making this equal to 44. We'll add 4 to both sides, and then divide by 2. Find the value of x is what they said. It's 24. Number 15. Distance from A to H, they're saying that's 5x minus 1. Distance from F to H, they're saying that's 3x plus 21. What's the value, what's the measure of segment AH? Well, these two segments are equal. They're congruent to each other. So 5x minus 1 equals 3x plus 21. We'll solve for x. We're going to subtract 3x from both sides. We'll add 1 to both sides. X is 11 in this problem. Notice how x is different in all the problems. That's not really a good thing when you're working on the same diagram, but whatever. X is 11, so let's plug it in. 3 times 11, that's 33. 33 plus 21 is 54. That's how far it is from A to H. In triangle ADF, that's the big one now. What's the measure of angle ADF? Well, this angle is 44, remember, so is this one. 44 and 44 gives you 88 for the big angle.